last two questions on your homework from Friday gave you pictures and asked you to write an equation for the graph that matches them. So when I look at this graph, my first question is, am I looking at a sine or a cosine? Cosine. How do you know? Right. Sine is always going to start at its 0 point. It's going to start in the middle. If it starts high or low, we are talking about a cosine graph. Okay, I know that much. Now cosine normally starts at its high point. So what happened on this graph? Right, it's flipped. So we know there's a negative in front. What is the amplitude if I look at this graph? 2. So that when you talk about the equation, the amplitude is in front. So I know it's a y equals -2 cosine. Now I just have to find my angle. Okay, what is the period of this graph? How long does it take to start repeating? 4 pi. Remember how we found period? We did 2 pi divided by the number in front of x, and it gave us the period. So that means 2 pi divided by the b has to equal 4 pi. So if I want to solve for b, we would multiply it over. Divide by 4 pi. And we get 1/2. So that has to be the coefficient of x. So my equation is y equals -2 cosine of 1/2 x. You can just look at the picture and tell if it needs a negative in front and the amplitude, and then the period you just worked out. 2 pi divided by b equals the length of time until it repeats. I'm going to put one up here and I want you guys to try to come up with an equation. Are there any questions on this one first? Here's yours. Is this a sine or a cosine? Sine. It's starting at the center, so I know that much. Did this one flip? No. What is my amplitude, my high point? 4. So that means there's a 4 in front. Period. Careful. How long does it take before this repeats? Pi. Even though I graphed it to 2 pi, after pi, this thing starts to repeat. So my period is just pi. That means 2 pi divided by the coefficient of x equals pi. Divide by pi, and you get b equals 2. So it's 4 sine of 2x. Any questions on that? And I'd like to start section 4.2 now. So we are going to look at translations of sine and cosine. So again, I'm still just focusing on sine and cosine for a little bit longer before we get into the others. We've talked about, changing the amplitude and the period of the graph. But we could also apply all of the other transformations that we've done before, moving things left and right, up and down. So today I'm just going to do the left and right portion, and then we'll save up and down for tomorrow. On our trig functions, when you move them left or right, it's sometimes called a phase shift. So on the homework, if it says something about the phase shift, that's what we're talking about. I'm just going to explain this with an example. I think that's the best way. So if I said y equals the sine of x plus 3 pi over 4. There are a couple options for doing this. If you know transformations, you know if you add to your x value, it moves your whole graph to the left. So you might be able to look at this and say, okay, I'm going to move left 3 pi over 4. But what that does is it throws off all of the other points, you know, r0, pi over 2, pi, 2 pi, all those. So what I do instead, I'm going to add another thing to our list. On Friday, we were doing amplitude, period, count by. The thing I'm going to add today is an interval. Okay, amplitude is the coefficient of sine. So what's my coefficient here? 1, so my amplitude is just 1. Period is 2 pi divided by the number in front of x. What's the coefficient of x? Just 1, so my period is just 2 pi. How did we get the count by? Period over 4, so 2 pi divided by 4 is pi over 2. Okay, new piece, the interval. What I want you to do is set it up. When we graphed the normal sine for the very first time, we started at 0 and ended at 2 pi. So for sine and cosine, we'll always set up our interval like this. It'll be from 0 to 2 pi. And in the middle, I want you to put this argument, the angle, the thing you're doing the sine of. Regardless of what the period is, you know, if this were a 4 pi, it would have changed my period. Set it up between 0 and 2 pi and put the entire angle in the middle. Now I just want to solve this inequality for x. So to get the x by itself, we would subtract our 3 pi over 4. And we have to do it to both ends as well. So we get negative 3 pi over 4 less than or equal to x is less than or equal to 2 pi minus 3 pi over 4. It's like 8 pi over 4 minus 3 pi over 4. So it should give me 5 pi over 4. Again, if you got confused there, you can use a calculator, just don't do pi. Just 2 minus 3/4. What this tells me is it gives me an interval to get one complete cycle of sine. So that means when I go to graph this, my first point is going to be at negative 3 pi over 4. And my last point will be at 5 pi over 4. So let's start graphing. Since you're not starting at 0, make sure you do give yourself a little room on the negative side. I am asking you to remember we talked about try to space things out evenly. So my very first point is at negative 3 pi over 4. How do you get, we had 5 total points before. 0 and 4 after that. Well, this is like my 0. That's my first point. I need 4 after this. How do I get those? Add your count pi. So negative 3 pi over 4 plus pi over 2, or negative 3/4 plus 1/2. You get negative pi over 4. If you add pi over 2 to that, you get positive pi over 4. We need 5 total points. So we've got 3, I need 2 more. Try to space them evenly. Plus pi over 2, 3 pi over 4. Plus pi over 2 is 5 pi over 4. And isn't that where we said our graph was going to end? So we know we've done it correctly. If you set up your interval, and you get your 5 points and you don't end where your interval ends, you have made a mistake somewhere. Okay, those two numbers should be the same. My amplitude was 1, so the high period is just at +1, low point at -1. We didn't flip or anything. We were graphing, was it sine or cosine on this one? Sine? Okay. All right. Where does the graph of sine begin? At 0. So at -3/4, I will be at 0. Then we go up. So at -π/4, we're at +1. Do I put a point at 0, 0? No, because when I added my count by, I did not get 0 as one of them. So my at π/4 is when we're back to 0. 3π/4 with -1. 5π/4 back to 0. Nice smooth curve, no corners, no straight lines. Look at that. I only asked for 1 period. If I'd said 2 periods, what would you do? Add 4 more points and keep going. So the new piece in this section today is that interval. We're not just starting at 0. We have to see where we start our graph. But otherwise, it's all the same. Any questions there? Amplitude? 2. What else is happening on this one? Flip. The negative will flip. 2π. Just 2π over the number in front of x, which is a 1. So period is just 2π. How do we find the count by? 2π divided by 4, pi over 2. And what's the new thing that we have to add in here? Always, yeah. And the next piece we need is the angle. So I will start it at 0, less than or equal to my angle, x minus pi over 3, less than or equal to 2π. It's always just going to be this argument, or angle, between 0 and 2π. So now if I solve for my x, I would add pi over 3. 0 plus pi over 3 is pi over 3. Less than or equal to x, less than or equal to 2π plus pi over 3 is 7 pi. Okay, now we're ready to graph. So I'm starting on at positive pi over 3, so I don't really have to worry about having a negative side here. Then you add your count by to get your next points. So pi over 3 plus pi over 2. Come on, somebody say it out loud. What are you getting when you add those? 5 pi over 6. Plus pi over 2. gives us 8 pi over 6 or 4 pi over 3. Plus pi over 2. We get 11 pi over 6. Plus pi over 2. It'd be 14 pi over 6, which is 7 pi over 3. And quick check, that's where my interval was supposed to end, and that's where I ended. So I'm in good shape now. Does everybody understand how I'm getting those points? My amplitude is 2. So high point positive 2, low point negative 2. Cosine normally starts at its high point, but we flip it, so it'll start at its low point. So do I put a point at 0, negative 2? No, we start at pi over 3 with my first x value. So at pi over 3, we're at negative 2. 5 pi over 6 is 0. 4 pi over 3 is positive 2. And then back down. Make sure your points are spaced evenly. Otherwise, your graph will come out looking funny. So keep in mind, it's not that cosine doesn't exist before pi over 3, it's just that we only graph one angle, or one period of it. But it would extend and keep going in both directions. Let's do another one. Take a second on your own. See if you can go through that list of information. Don't start sketching the graph until we make sure you're correct, but see if you can do your amplitude, period, count by, and interval. Amplitude, 3/2. Period is 2 pi divided by 2, which just gives you pi. Count by, period divided by 4, so pi over 4. Interval, you take your argument and set it between 0 and 2 pi. So 0 less than or equal to 2x minus pi, less than or equal to 2 pi. If you're solving for x, what do you do first? Add our pi. So 0 plus pi is pi. 2 pi plus pi is 3 pi. Divide everything by 2, so pi over 2 less than or equal to x, less than or equal to 3 pi over 2. Okay, so we're trying to space things evenly. Keep in mind your first one is at pi over 2. That's like 90 degrees. Then you're adding pi over 4 each time. That's like 45. Okay, so pi over 2 plus pi over 4 would be 3 pi over 4. Plus pi over 4 is pi. Plus pi over 4, that's 5 pi over 4. Plus pi over 4 is 6 pi over 4, or 3 pi over 2. cosine, which starts at its amplitude. So at pi over 2, we have to be at our high point, which is 3 over 2, 1.5. And it goes down to 0, down to negative 1.5, and back up. Am I done? I asked for 2 periods. When we did these Friday, we usually just kept adding pi over 4 onto the end, and you could certainly do that and get 4 more points. I also want to show you, you could go the other direction. You just have to subtract your count by. So pi over 2 minus pi over 4 is pi over 4, minus pi over 4 is 0, minus pi over 4 is negative pi over 4, minus pi over 4 is negative pi over 2. You don't have to go the negative direction. I just want to show you. If you extend to the right, you keep adding your count by. If you go to the left, you subtract your count by. So sometimes if you are running out of space in one direction, you might go the other. And then, of course, our pattern continues. So at 0, negative, and back up. Would you guys like more examples of moving our graphs left and right? So we have quite a bit of time left, but I am going to go ahead and stop there. So I'm adding 7 problems to what I gave you before. Do I want to do all of it? I'm going to take off 29. So 6 more problems to what I gave you Friday, and then both of these assignments are due tomorrow. Then we'll finish up this section.